So section 1.2 discusses the scientific method, or as Trow says, the scientific approach to knowledge. Now, in order to discuss the scientific method, we'll need to define several terms, and we'll give a couple examples. So first of all, scientific knowledge, as Trow states on page 5, is empirical. Scientific knowledge is empirical. What is empirical? Empirical means based on observation and experiment. So observations are not defined by Trow. It might be self-evident, but I'm going to ask you to look up the term observation and give a definition of that with a citation. So observations can be either qualitative or quantitative. Qualitative means it's noting or describing how a process happens, or qualities of a process, okay? And quantitative means measuring or quantifying something about the process, right? So those are on page 5 of Trow, as I said. All right, now, a hypothesis is a tentative interpretation or explanation of observations. A hypothesis is a tentative interpretation or explanation of observations. All right? The experiments are highly controlled procedures designed to generate observations that can confirm or refute a hypothesis. Experiments are highly controlled procedures designed to generate observations that can confirm or refute a hypothesis. Okay? A scientific law is a brief statement that summarizes past observations and predicts future ones. And finally, a theory is one or more well-established hypotheses A theory is a model for the way nature is and tries to explain not merely what nature does, but why. A theory is a scientific model for the way nature is and tries to explain not merely what nature does, but why. Okay, so let's give a couple examples. To look at the first example of one of these terms, the law, I want to discuss the law of the conservation of mass. And to do that, we're going to look at a scientist named Antoine Lavoisier. So Antoine Lavoisier was a French chemist who studied combustion. He made careful measurements of things when he burned them, right? So he would take something in a closed container and he would burn it in a closed container. And he made careful measurements of the masses. And he found that in a chemical reaction, and here's the law of the conservation of mass, the first example, he found that in a chemical reaction, mass is neither created nor destroyed. Mass is neither created nor destroyed in a chemical reaction. What does that mean? So let's look at this. So suppose we've got some reaction which we're gonna give as an example, a car with wheels. All right, and in the reaction, we've got a car. Suppose that the chemical symbol for a car without wheels is BD, right? So it turns out that scientists used to think that a car without wheels was just a body, and so the scientists gave the chemical symbol for a car without wheels as BD, body. And suppose the chemical symbol for wheels was WH, all right? And then suppose after we put that together, the chemical symbol for a complete car is KR. This was before we knew about krypton. Now, how many objects exist in this reaction before? How many objects exist? So there's 4 wheels, 1, 2, 3, 4. And there's another object here, a body, right? So we're going to call that 5 objects. Can you see that? There'd be a 4 here. Actually, I can do that with a pen, can't I? Let's go here. Put 4. Oops, wrong. there's only one body. Oops, just a second here. Go back here. There's only one body, and there are 4 wheels, right? So how many objects total are there in this first picture? There's 5, right? 1 body and 4 wheels. Now, after we put the wheels on the car, or the body, and we find we have a complete car here, how many objects do we have? Only 1 car, right? So it went from 5 to 1. So how many objects exist before the reaction? 5. How many after? 1. What happens to the number in this reaction? Well, it changes or decreases, right? Okay, suppose each wheel weighs 80 pounds, okay? Now this is the number, but let's do the mass below it, okay? Suppose each wheel weighs 80 pounds, so this is going to be 80 pounds, and there are 4 of them, right? And each wheelless car, which is a BD, is 1,200 pounds, okay? So how many pounds do we have total in the beginning? It's 1,200 plus 240. Looks like that's 1,440. Okay? Now, how much mass do we have? In the beginning, we have 1,440 pounds. How much mass do we have in the beginning? In the end? Well, we still have the 4 wheels, right? And the body. So it's going to be 1,440. Okay? So suppose each wheel weighs 80 pounds and each wheelless car weighs 1,200. How much do all the objects weigh before? Oops, it's spelled here. Before the reaction, it's 1,440. How much after? 1,440. What happens to the mass in the reaction? It is conserved. Okay? And that is the law of the conservation of mass. All right, so let's look at the example of Mr. Lavoisier. How many molecules exist before the reaction above? So I'm asking you to assume here that this is a molecule, there's a molecule, there's a molecule, and there's a molecule. We know the name of this molecule, right? That's water. We know from last meeting, or the last section, that the name of this is carbon dioxide. This is oxygen, molecular oxygen, right? What I didn't tell you is that this is ethane, and you would have no way of knowing that. So, all right. So, how many molecules exist before the reaction? If this represents 1 molecule of ethane, this represents 1 molecule of oxygen. There's 2 of them, right? 2 plus 7. So, how many molecules are there? Well, there are 9 beforehand. How many are there in the end? 10. What happens to the number of molecules in this reaction? It changes, right? Actually increases, right? Okay, suppose Antoine Lavoisier was able to measure 60 total grams of ethane. Now let's do the mass. Here's the number. Let's do the mass here. I'm just going to use this as my column heading. Suppose he did 60 total grams of ethane and 224 total grams of oxygen gas. How many grams of carbon dioxide and water would he have measured as products of the combustion of ethane? Okay, I'm going to leave that for you to answer on your own. How many grams of carbon dioxide and water would he have measured as products of the combustion of ethane? Well, I'm going to give you a hint. The hint is that this is about the law of the conservation of mass. All right? Okay, so the law of the conservation of mass says that in a chemical reaction, mass is neither created nor destroyed. Whatever material you have before reaction, you still have when it's over. Genius. Absolute genius. Okay, so for our next example, we want to look at a theory that was probed by another scientist named John Dalton. Okay, Dalton explained the law of the conservation of mass, as well as many other things and observations at the time, by proposing that mass is composed of small, indestructible particles called atoms. Let me read that again. John Dalton explained the law of the conservation of mass and many other things by proposing that matter is composed of small, indestructible particles called atoms. That was John Dalton's theory. Matter is composed of small, indestructible particles.